Hello everyone. My name is Asaida. I'm from University of Sriwijaya. Please allow me to present our research result. The title is Analysis of DCO FDM application in MyMonoma VLC system serving 8 users. So the outline will be consist of 3 sections. The brief introduction section about the research, then how the research is modeled and simulated, and what is the result. As the IoT era trending, the bandwidth requirement for daily communication like TV broadcasting, online meeting and streaming is become enormous and increased by multifold. But the radio frequency that provides the bandwidth is no longer sufficient for the needs. Therefore, Siebel-like spectrum, which has 10K times RF bandwidth, now become an alternative to complement RF communication, known as visible-like communication. Wi-Fi, as we know, already popular use in every campus, office, mall, and private house. In a house, TV, laptop, and mobile phone are connected to internet via Wi-Fi, but the problem called Wi-Fi spectrum crunch appear as the connected devices increase because of sensors and etc. These devices require broader bandwidth as VLC can provide. So the objectives of our research is to obtain the parameter and analysis required for VLC implementation serving 8 users, and the simulation result considered as a valid result because we had demonstrated one LED serving 2 user equipment in the experiment. In the past, we modeled a research where one LED serves 2 user equipment by differentiate their signal power using NOMA mechanism. In the experiment, we had demonstrated our work where one LED serves 2 user equipment use UE1 and UE2. A WG send data signal to white LED. LED transmit the signal to photodetector 1 and photodetector 2, represent as UE1 and UE2. The received signal captured by a real-time oscilloscope and decoded using a computer. So in this research work to model a VLC network serving 8 users in total, MIMO network is used with configuration 2 by 4, meaning there are 2 LED, TXA and TXB, each TX serving 4 user UE1 until UE4. So if we consider the transmitted signal from TXB as 100% level, at some point where user equipment of the neighbor TXA can receive the interference signal, the percentage will decrease into some level. Here we consider as 100 minus Z percent. The level of interference are varied, and about to find out in the simulation result what is the minimum SNR required to hold the level of interference from the LED neighbor. The modulation technique used in this VLC system is DCO OFDM combined with NOMA, as shown in the schematic diagram. First, the data for each user is mapped into 4 QAM symbol before fed into IFFT to produce OFDM signal. and then the OFDM signal of every user is allocated with different power. Here we symbol as A1, A2, A3, and A4. And then the produced signal X1, X2, X3, then and X4 T are superposed into single transmitted signal XT. Uh, so the LED will transmit this XT into VLC channel, and in the receiver of E1, user 1, user 2, user 3, and user 4, um, since we model that user 4 has the lowest SNR, therefore this user will get the highest power P. So because of this P, this power, the highest power, user 4 can directly decode Y4T through zero forcing algorithm by considering X1T, X2T, and X3 that include in the Y4T as noises, while user 3, user 2, and user 1 must perform SIC algorithm several times as described in the diagram. SIC procedure is run by following the steps in the RX, which has the higher power allocation, and to find the user's data. By finding the user's data, the the corresponding receiver can repeat the modulation process uh, to obtain its transmitted signal. If the transmitted signal found, so YET can subtract the signal to get XIT. I refers to the receiver which has the lower power allocation. Now we come to the simulation results section. As we can see in figure 7, where the situation is level of interference, or LOI, is 0, the minimum required SNR of transmitted signal by TXA is 26 dB. Otherwise, the bit error ratio, or BER, will be over the FEC limit. If the level of interference, or LOI, is increased into 1%, uh, meaning that signal from TXB received by UE1, UE2, UE3, UE4 is 1%, each of the user equipment. So the minimum SNR, minimum power of SNR transmitted by TXA is must be over 26 dB to get the bit error ratio below FEC limit. So how about if the LOI is 2%? Uh, we can see that in this figure, uh, 27 dB from transmitted signal of TXA cannot hold the interference, because we can see that the bit ratio is uh, over the limit, the threshold here. So uh, the transmitted signal of TXA must have the SNR uh, above 27 dB to maintain the bit ratio below FEC limit. And the 28 dB of SNR transmitted signal TXA uh, is not enough to hold the uh, LOI of 3% from TXP signal. As we can see in this figure, uh, the the user, the bit error ratio of every user, U1, UA2, UA3, and UA4 is below FEC limit when the SNR signal is 30 dB. If we refill the constellation diagram of MIMO 2 by 4 network, as can be seen from the figure A, where the interference level is low, every user 1 till user 4, have a clear constellation point compared to figure B, where the interference level is high. Um, we also can see that every user 1 until user 4, have different pattern of constellation diagram. Uh, this is happen because we know that user 4 demodulated all the signal, meaning the other user signal is there. So the point, the constellation diagram is also showing in the diagram, while user 1 it only has the original point of 4 QAM because the receiver subtract all other user signal from its own signal, its own original signal. So therefore only 4 point we can see here in the diagram. So what is the conclusion of our work? An investigation of a MIMO-NOMA VLC network serving 8 users using DCO or FDM scheme had been done. Analysis of the bit error ratio performance in different channel noise and interference level variation from neighbor transmitter uh, show that to achieve bit error ratio below FEC limit, the minimum SNR should be above 27 dB in 1% LOI, 28 dB in 2% LOI, and 30 dB in 3% LOI. Without any interference, 26 dB of SNR of transmitted signal is sufficient to maintain the BER under FEC threshold. Thank you very much for your attention. Thank you.